So welcome to IQ online class. So today we're going to look at engineering science. Specifically, we're going to look at the linear motion. We did angular motion and projector motion. You can check out other videos. We also did some derivative questions there. Okay. So now here on linear motion we have this question. Okay. So now what I want us to do is this. Before we look at this question, okay, I want us to look at what linear motion is and some of the concepts which you need to know. Okay, so this is the one of the types of what motions under dynamics in engineering science or physics. Okay, so let's look at this linear motion. Okay, what is linear motion? What is linear motion? Okay, what is linear motion? So linear motion in simple terms, we can just say linear motion is a motion or movement is a motion in a straight line or path. That is basically what linear motion is. So linear motion is just motion in a straight line. Now, what do we need to know? Okay, this linear motion deals. So the other point, it deals with the speed. Okay. You can measure speed of something which is moving in a straight line or path. So it also deals with velocity. Okay? It also deals with what? Acceleration. Okay? So there are many things which do, maybe you can also include the displacement and the like. Okay? So basically this is what linear motion deals with. Okay? So now, to answer, for example, such questions, you need what we call equations of linear motion. But in a derivative question, they may ask you to derive those equations. So first of all, let's start with speed. Speed, of course, I'm sure is simple to most of us. Okay, because speed, you just say when you look at the speed, you are just measuring, okay? You are just measuring the position of something with respect to maybe the distance something has covered with respect to time. So for example, you just say, oh, speed is equal to distance over time taken there, okay? So this is basically the formula for what? For speed. So now, quickly now, let's come to velocity, okay? When you look at velocity is the change of what? Change of displacement with respect to time. Okay? With what? With respect to time. With respect to what? To time. So it means velocity is equal to displacement. Under displacement, we can use S, okay? Or meaning, or velocity can also be given by x over t, where S is what we call displacement, measured in what? Meters. Then time, t is what we call time, okay? T is what we call time, of course, taken in what? It's a basic quantity, fundamental unit there, in this case, seconds, okay? So it means units for velocity is, meter per second there. You need to get like that, okay? So velocity is measured in what? Meter per second, okay? So since we know the formula for velocity, Okay, we know the formula for what? Velocity, which is just the change of what? Change of displacement to what? Time. Okay, let's look at now before we move to the next one, let's look at average. How do you find average velocity? Okay, so how do you find the average velocity? So average velocity, of course, you add final plus initial over what? Over time. That is how you calculate the average. This is the average what? Velocity. Okay? So average, you add final velocity plus initial divided by 2. Since you want to find the average, you divide by what? By 2. So now next, let's move to, we'll derive all the equations here. Okay? Let's move to acceleration. Let's move to acceleration. Now, before we move there, we need to, let's put this somewhere here, okay? So average velocity, we are saying that this is v plus u over what? 2. Okay, let's keep this one. Then we are saying that velocity is just s over what? Over t. Okay? S is equal to what? Over t there. Okay? So now, what are we saying? Okay, let's keep these what? Equations here. Okay? So now let's come to acceleration. We need to discuss these parameters before we look at the equations. Acceleration. What is it? Acceleration. Acceleration is the rate change of what? Velocity. Simple and straightforward. Is the rate change of what? Velocity. In short, the change of velocity with respect to time is what we call acceleration. So acceleration, we use small letter a in science to represent acceleration. So it means acceleration is equal to change in v over what? Time. So this is delta. Okay, so of course change in velocity, you have what we call final velocity and initial where you're starting. So it means acceleration is equal to final velocity minus initial velocity over time. Okay? This is final velocity, initial velocity divided by what? Time. So this is the what? This is the formula for acceleration. Okay? This is the formula for what? Acceleration. So now when you look at this equation here, okay? Now let's not forget units. What are the units for acceleration? Units for acceleration are meter per second what? Squared. So acceleration is measured in what? Meters per second what? Squared. Okay? So it means we also have another equation here which we can put. So this one, let's put another one for acceleration. So acceleration is equal to v minus u over what? Over t. Okay? So now I want us to do this. Okay? We have this equation and that one. I want us to combine those. Okay? I want us to combine those equations. Okay? So we have the formula for velocity and that of average what? Velocity. So I want us to combine those. Let's see what we get. So, for example, here, let's make displacement the subject of the formula in this equation here. So you find that since v is equal to s over t, okay? So here, s is equal to v what? Vt. So now, s is equal to, where there is v, okay, let us substitute with, because this is velocity, here we are given the what? The formula for average what? Velocity there. Okay? So where there is v, I'll put that formula there. So here I will get v plus u over 2. Everything now will be multiplied by what? by t. So this is one of the equations of linear motion which you need to know. Okay, this is one of the equations of linear motion which you need to know. Okay, let's keep this one here. Okay, then again, let's do this. The other equation, okay, from this equation of acceleration here, since we know that acceleration is equal to v minus u over t. Okay, so let's do this. Let's cross multiply here. Okay, so 1 times v minus u is v minus u is equal to, this time that you will get what? 80. So in this equation you find that v, okay, is equal to, when u goes the other side, you have u plus a what? A. This is one of the equations of what? Linear motion. That is one of the equations of what? Linear motion. So this is one of the equations of linear motion. So we have two here. Okay? So now, what are we going to do next? Keep this very safe. Okay? What are we going to do here? What if now we try, since we know that v is equal to this one, let us now substitute equation 1. Let us substitute equation 2 in equation 1. So what are we doing? What are we doing? So let's get this one the way it is. So we are saying that substitute that equation 2 into equation 1. So what are we saying? Where there is v, we put, since v is equal to u plus 80. So where there is v, we try to put what? U plus 80. So in this equation here. So what are we saying? Since s is equal to v plus u over 2 divided by t, so meaning s will be equal to, where there is v, we are putting u plus 80 here. So where there is v, we are putting u plus 80, okay, plus this is u, okay, so over what? Over 2, everything is being multiplied by t. So s is equal to, okay, these are like terms which you can add. So this is u plus u, you get what? 2u plus, here you just remain with what? 80, okay, over what? 2 multiplied by what? By t, okay. So when we distribute this t into the brackets there, we get s will be equal to t times 2u, you get 2ut plus t times at, you get at squared, okay, over what? Over 2. Now you need to know that this 2 is on both this one and that one, so you can split it. So s is equal to 2ut over 2 plus at squared over 2, okay, so that these 2 and that 2 can go. So s is equal to s, which we call the displacement. S is equal to ut plus, okay, of course here if you want there is 1 there. So this is 1 over 2 at what? Squared. Okay, so meaning this is another equation of what? Linear motion. So we are deriving. This is one of the equations of what? Linear motion. Okay, so you need to know. So we have 1, 2, 3. Let's get another one here. Let's get another one here. We are coming back there. Okay, we are coming back there. So let's do this. Let me break this back here. So keep this equation. That's how we are getting it. So we have this equation here. V is equal to u plus 80. Okay, can we try to make t subject? Okay, yes, this is v minus u. This is equal to a t. Okay, let us try to divide. Let us try to divide a on both sides. So even there, yeah, but this one, that one. So T is equal to V minus U over A. Let's keep this equation here, okay? Now let's go back here. We have this one here. S is equal to U, rather V plus U over 2 multiplied by what? By T, okay? So now we are going to substitute. Since T is equal to this one, and it's also in that equation, so we'll substitute this one there. Okay, so meaning that S is equal to V plus U over 2 multiplied by, where there is T, we'll put V, where there is T here, we'll put V minus U over A, like that. Okay, so S is equal to, okay, we can try to, we can now multiply that, okay? We can now what? Multiply that. V times V, you get V squared. V times UV, you get minus VU. V, U times V, you get plus VU. Then this time that you get minus U squared. Everything divided by 2 times A, you get 2A. Okay? So now, there, here, S is equal to, okay, this one here will give us what? 0. So on top will remain with V squared minus U squared over what? 2A. Okay, so since this is a fraction this side, we can also say over 1. Okay, we make it a fraction there, then we cross what? Multiply. Meaning that 1 times all that you get V squared minus U squared is equal to S times 2A, you get 2AS. Okay? Now, so the final equation there, we can take this U squared to the other side. So it means from there we have this one here. So it means V squared is equal to U squared plus 2AS. So this is another equation of what? Linear motion. So now this is how you derive these what? Equations. So now I'll write them for you here, the equations which you need to know. Okay? But this is how you derive them. This is one of them. This is one of them, very useful. So you can name this one as equation 1. There is also this one here. We can name this one as equation 1, 2. So we have also this one which we derived here. V squared is equal to U squared plus 2AS. Okay? That one can be our equation 2. And this one here, S is equal to UT plus 1 over AT squared. So now we have done we have now shown how to derive these equations. So these are the equations which you need to know. So S is displacement, V is final velocity, U is initial velocity, T is time. Just like that in those. Then A is the acceleration. So what you need to know when you are using these equations, all the parameters there should be in there in terms of units that you should work with basic or fundamental units. For example, time. When time is given in hours, make sure you convert it to seconds. When it's given in minutes, you convert it to what? In 2 seconds there, okay? So now, let's look at the question. Having, since we are now acquainted with the equations, we can now answer this what? Question here real quick, okay? You even show us which equation we can use there, okay? So now the question reads, a train starting from rest. Starting from what? Rest. So already just this word here, rest, it will tell you, say, oh, the initial velocity there is 0 because it's starting from what? Rest. Okay? Is uniform accelerated during the first 0.4 kilometers. Of course, this one is distance or displacement. Runs 1.2 kilometers at the maximum speed attained and is afterwards brought to rest in that one there. So if the time for the whole journey is 5 minutes, so find the acceleration at the, so find the uniform acceleration at the start, or in short, just find the acceleration of the journey for the journey there. Okay, so find the acceleration for the journey. Find the acceleration for the jump, or just at the start of this object, in this case train. So now, what are we going to do here? Okay, looking at what we are given, yes, we have, let's get data here, the data from the question. We are given the initial velocity, in this case, since it is starting from the rest, in short, initial velocity is 0 meters per second there. Okay? Okay? Then, that's what we are given. We're not given the final velocity. We're also given the time. Okay? The time for the whole journey. So the time for the whole journey here is 5 minutes. 5 minutes. So now, these 5 minutes, minutes are not the SI units for time. So we need to convert minutes into what? Seconds. So what are we saying? Since 1 minute has this second. So we just say 5 times this, of course, which will give us 300. So meaning 5 minutes is equal to, we are just saying that this seconds times 5, this gives us what? 300 seconds. So that is the time. What else are we given? We are given this distance, we are given about 2. So now also, since they are in kilometers, we need to convert them into what? Meters. Okay? So the first one which we are given is 0.4 kilometers. So it is very easy. When you are converting from kilometers to meters, just multiply by what? 1,000. So this one times 1,000, it will give us 400 what? Meters. That is 400 meters. This 0. Okay, we have this other distance here, which is 1.2 kilometers. Okay, times 1,000. So this one will be equal to 1,200 meters. Okay, so you keep that answer there. Let's come to this one here. 0.2 kilometers times 1,000. So this one is equal to 200 meters. Okay? So now here we need to find the total displacement, okay, of the given these displacements here. Okay? So total, we just have to add. Okay? So on the data there, let's also add the total displacement, which is S. So displacement will be equal to, we are going to add 400 plus 1,200 plus 200, okay, meters. So meaning displacement is equal to, when we add this plus that will be, that is 1,600 plus that one. So this one will be 1,800 what? Meters. So now, looking at what we are given here, we have initial what? Velocity, time, and displacement. And we don't have what? Acceleration. So now, when you come back to the equations which we've derived here, okay? When you look at what the parameters which we are given here, the equation which we can use will be this one here. Because in this one here we have time, initial, and also the displacement. Not only that, also what we are looking for, acceleration. So we use this equation number 4 here to answer this question. Okay? So now just a matter of substituting. Just a matter of substituting now, okay? So we are using this equation here, which is S is equal to UT plus 1 over 2 AT squared. So displacement, we are getting the total displacement, which is 1,800 which is equal to initial speed is what? 0 times the time, which is 300 seconds plus 1 over 2. Acceleration is what we are looking for. Time is 300. So 300 raised to the power 2 there, okay? So 1,800 will be equal to, this time that is 0, so this is 0 here, give us 0, plus 1 over 2a, so now we need to, would give us 90,000, or let's do this, so 300 to the power 2, we are getting 90,000. So here, this is 90 what? 90,000, okay? So what are we saying? 9,000 so 9,000, okay, here we can reduce that. So this is 1,800 will be equal to, this is now 90,000, okay, A over what? Over 2. So 1,800 will be equal to, when you divide that, you get 45,000 A, okay? So now we want to find the value of A, which is acceleration. So you divide by what? 45,000. Even here, 45,000, so that this one and that one goes. So meaning A is equal to, so 1,800 divided 45,000 is giving me 0.04 meters per second squared. So this is the acceleration of that train there at the start of the jump. So basically this is what we need to know under linear motion. Of course, we upload more questions from the Deriving papers, so we can end here.